Sorry, such a small room. I'm going to move that down a little bit. All right. We'll see pretty quickly what we're talking about. And there are two questions that I have up there that I always come back to. One, when people think of automation, just like you were talking about, it's like, well, can we do it faster? And almost always you can, if you can identify what the rules are and automate those. But as you're going to see here, that's only the tip of the iceberg. It's all of the things that it makes possible that you couldn't do until you started using the automation. So we'll see that too. Then we'll look a little bit as to what the implementation took, and we'll wrap up. Like I said, I love an intimate group like this. At any point, if you want to take us tangentially and say, what about this? Or ask us about one of your particular applications, and let's take this where it's most important to go for the benefit of everyone. So with that, Landy,
okay,
come on down.
Okay, you just want me to do the
Yeah, let's do the crate.
You just explain what's going on.
Sure. So the value message behind this particular product is that they're reusable crates, and I'll show you some pictures, that one person can snap together. They're all machined to plus or minus 10,000ths of an inch, all the panels, all routed. And without any tools and minimal training, you can crate just about anything. And you'll see some pictures and some examples. They're used. Yeah, it's getting a little louder. I was asking Landy, I was like, are these going to sound like gunshots? And as far as strength and durability, these things can be used hundreds, thousands of times round trip. And so, how many times did you say, Landy, this one you think's been taken apart and put back together?
We still have our original one that we started off showing about 10 years ago. And this one has been put together hundreds of times. It's gone to 3 different trade shows.
And the other one, he said the original one, he said probably 5,000 times and put together and so forth. And then in terms of, strength, which was the other thing that amazed me about this, was Landy was telling us about some testing that the military did on these. You want to share that story one more time?
Sure. I'll get up to the pedestal.
All right.
You can interrupt.
Sure.
These crates have been tested to hold 4,000 pounds of live ammunition. And the government that was, the Air Force base that was doing the testing, after they got done testing our 46 by 46 inch version, it was filled with sand to simulate the ammo. They had a large hill next to their facility, so they decided they would take it up to the top of the hill, pick it up with a forklift, and just topple it end over end going down the hill to see what would happen. And the clips did not fail, the crate did not fail. One stringer hit a rock on the way down probably, and it cracked it. It didn't fail, but it did crack it. But there was no scientific data to prove that.
So, in any case, bottom line, the reason, like I said before, the reason that I'm fascinated by this product is just simple. Sometimes the simplest things are the hardest to get right. Even in the design automation space, sometimes the things that are very simple but highly configurable are challenging. So let me show you some pictures. All right, so what is a quick crate? Yeah, here's an example. Here's several examples. Is this green one the original one?
Yes, that green one is the original one.
What was that one for?
I honestly don't remember. I know what that one was
I know what that one was for. All right, let's go straight to SolidWorks. This was 5 minutes worth of introduction. Yeah, go for it. So actually, why don't you close that just for a sec, close the model and just,
Okay.
oh, not SolidWorks.
Oh, sorry.
That's all right.
Oh, okay.
All right, so what the solution looks like that we put in place for them enables you to fire up SolidWorks. There's a master model that's been created of a crate. And then there's an interface that is supplied by an add-in created by a company called Tacton. And it enables you to create a completely customizable interface for punching in your customer's requirements. And in this particular case, so we're doing this crate here, configuring the length, the width, the height. It is taking that model, taking the information for the customer requirements, and pushing it out to an engine that's evaluating what all of the parameter values should be, and then pushing those back and updating the SolidWorks model. So if you look at a given crate, you can imagine length, width, height, etc., as well as the numbers of clips and so forth. There are going to be design rules defining the relationships between those parameters. If you're doing this manually, you are either starting from scratch, building a model, calculating all of those values based upon your experience in designing the crates, and then you are making sure that all of the relationships match and doing things one by one. So they previously had been spending an hour or two figuring out all of the placement of things like clips, the placement of slots, so forth. And as you see here, it takes them about a minute now. So for every crate that they do, the design time is reduced by an immense factor. However, actually, go back to SolidWorks for a second. Once they get to this point, though, by exporting this, yeah, go for it. It's automating the process of all of their drawings, all their stringers, etc. It is generating DXF files, which we'll get to later, for every panel, and sorting it out to a particular place on their server. So if you go to the desktop right now, or just that folder, for example, you'll see it's created a folder location for them for that particular job, and all of the files in one place. Just right off the bat, any questions about what you've seen so far? Okay.
Do you have another job then at the same size?
Say that again? Yeah, different. If you have another job of the same size, so what they wanted to do, and we'll get to this, is they wanted to be able to create an approval drawing for every job that they do. And completely repeated. Yeah. They don't try to reuse their parts, is a quick answer. Partially because it's so quick to generate a new one. So here, let's flip back to that, and actually just quickly jump through. Okay. So here are a few more examples. Trade show booths, pets. Yeah. So we were going to run a few of these, but I don't want to belabor the point and waste time necessarily or unnecessarily. Long and short of it is, if they do 5 of these, you'll see the same process repeated that you just did. So yeah, hold on, try it again. Is it changing?
Yeah.
I'm sorry.
That's ammunition.
Okay. Here, I'll just flip through.
Okay.
Okay. So let me tell you a little bit of the backstory behind this. About a year ago, I cold called the president of this company after finding their crates on the web and talked through the vision of what we might do for them. And of course, reduce time, increase efficiency, reduce mistakes, and so forth. There were a few problems. The first was, he's like, that sounds great. Thank you. But we don't have SolidWorks. In fact, at that point, they were doing minimal drawing at best. They were using AlphaCam for their cam, and anytime a customer required any type of a approval drawing, which they almost never sent, they would have one of their guys try to create it in AlphaCam and generate some line drawings to send over to them. So the chasm between even being able to utilize a solution like this seemed a little out of reach for them. The other issue is that they just purchased a 125,000 foot
Yes.
new facility,
125,000 square feet.
and they were feeling a little cash strapped. And so they said, it sounds great, it looks great, we can't do it now. And a month passed, I called them up again, another month passed, I called them up again. About 6 months later, he calls me up and says, how quickly can you put something like this in place? Because they were about to lose one of their engineers who'd been working there for a while, had a lot of knowledge that was about to walk out the door, and their business was ramping up, so they were going to have a double whammy situation where they're losing knowledge at the same time that they needed more production. We said, weeks. So it's a pretty simple product. So we got the ball rolling, and so in preparation for this talk, I had a call with that president and said, okay, now that you've been using it for 6 months, what have you found? And the next several slides are all his words about what impact it had. So the first thing was that, again, they didn't have anyone who knew SolidWorks. They went from 0 to everything that you've seen now, plus some more that you will see in
6 months.
6
Actually,
months,
less time
a lot
than that.
less.
The first drawings, I think, have dates on them.
Okay.
And you can kind of see the progression of the different dates that are on there.
Okay. So one major selling point, or one major challenge or hurdle in the SolidWorks community is going from 2D to 3D. And this is a situation where when you can set up the rules to define your standards and your process, it enables that transition to go much more smoothly for certain companies, of course. The second thing that he said was, we had 3 people who were designing crates, and you asked any 3 of us to quote a certain job, you would get 3 different designs. It'd all be somewhat similar, but none of them would be exactly the same as to where the clips were placed, as to the spacing between clips, what was the maximum allowable spacing between clips. There were general rules, but nothing standard. By utilizing this, they could agree on one, and anyone who used the system, Landy, and now you're bringing someone else on, is going to be creating exactly the same crate each time. The third is the standardization not only of the designs, but of the modeling from a SolidWorks standpoint. One of the things that I've seen being in this industry for a long time is that, and you all know this, you can model any given part in almost infinite number of ways, depending upon your style, depending upon your experience, so forth. And what this utilizes is that master model approach where you take your best designers, you take your best engineers, and you design it exactly the way that you want things modeled the first time. And then every subsequent job utilizes that, changes the parameters, and is modeled in a standard way throughout the company consistently. Number of benefits to that, but one of the most obvious ones is anytime someone needs to go into a project that they didn't do, they don't have to figure out why it was modeled the way that it was, because everyone knows exactly how it's modeled. Next piece, and I'll compliment Landy on some of the work that he did even after we put this in place, was that we've nearly eliminated what happens, the amount of time after an order comes through. Because what you just saw a few minutes ago was the creation of the DXF files for every panel, for every side of the crate. And because we're using that same master model, and different people aren't modeling it, and all of the features are always exactly the same, those DXFs that get produced are always going to be 100% consistent. So what that has enabled is us to take, or QuickCrate, to take for the tool paths the given DXF, identify certain rules around those DXFs, like, for example, the slots, the ways the slots are drawn, the size of the slots are always going to be the same. So do things like take the area inside of the slot, and anytime you have the same area, run this toolpath on it. And so in a 30-second process, they can generate toolpaths in AlphaCam for every panel of every crate that they did. So when you combine that with the ease now of generating those, the result is that you can quote as many crates as you have time to, and in this case, you have a lot of time, and as soon as a customer says, all right, we want that crate, 30 seconds later, it's ready to go to the machine. That was another thing which the owner of their company said was a pain point, because it was taking them an hour or two to create all of the cam and all of the tool paths when that order came through. And again, they're doing QuickCrate as a company, their major value sell is customization. Every one of those crates that you saw at the beginning, many of them are one-offs. They do sell standard crates, but I think you said 95% of the crates.
Are customized for the customer's particular application.
So pretty significant time reductions, you can imagine, when you have that many individual crates, they're all customized, and you're reducing 1 to 2 hours of engineering time for each one. From an engineering standpoint, you can imagine that their customers often need help in designing the crates. And again, in some of the pictures that you saw, some more you'll see in a second, there's a question of what does the inside of the crate look like? So depending upon the products, you'll have different customized dunnage. When you're doing design automation, I think I have a couple slides here. Well, I can speak through these. But when you're doing design automation, there's that question of how much do you automate? Do you automate a turnkey solution where someone punches in the customer requirements and on the other end spits out everything, always the same? Or I think of them as rough tuning and then fine tuning knobs. Oftentimes you're going to hit a point where the first 50% of every job is the same. The first 80% of every job is the same. But then the dunnage, for example, is unique to every job. And in that particular case, having a solution which automates the first part, giving you back time to do the latter, enables you to do more than you could have if you had to spend as much time on the first part as well. So here, this is kind of what I meant. I was amazed when we checked back in a month or two after we put the system in place, just how much actually Landy was doing, who started using SolidWorks at day one when they received this. And what he started doing was taking those models that we were initially creating, taking even the approval drawings that were being created, but then adding additional customization. And of course, because the SolidWorks drawings were all tied to the models, he could rapidly create things that looked similar but fairly different.
Notice the time date on that first one that you showed with the chairs. That was a big contract we got, and that was 18 days after you gave us the software.
Oh.
So, September 18th.
Landy was saying that on some days he was generating 10 or more complete quote assemblies a day, which again, when we talked to the owner, he said we just didn't do that before. When we had quote requests, we picked the ones that we thought were the highest value, and we spent time there, and we mostly avoided a lot of the others, or gave some high back of the envelope quotes, but didn't give them any attention. And now they're able to treat them all the same. So flip through a few of these. Is that trade booth?
Yes, that's the trade show booth.
Oh, the dimensions? Yeah, so no, we do it in the on the drawings themselves. So we have we're actually they're tied to the models, of course. So when the models change shape, the values are updating. We're then pushing in some additional values so you can get sort of the dual dimensions, the external. It's completely automated.
So
Yeah, totally good question. Where do you pull those dimensions off of? Let me show you that when we look at the implementation. The challenge, but I'll give you sort of a quick answer to that. Some of the challenges to design automation are when things are changing. Actually, you know what? Let me take this moment to sort of back up and talk about what we're doing with Tacton and what's happening in general. I think of this as fly-by-wire. That's the metaphor that seems to make the most sense to me. So in modern aviation or in whatever comparison you want to use, there's this idea that you move the joystick, and instead of that being mechanically connected to your rudders, your wings, your flaps, instead it's pushing a request to an onboard computer that's evaluating all of these different constraints of the system and pulling data from many sensors and identifying how much to move those flaps. And then it's pushing values out to the flaps to move the flaps. Right? So there's this feedback loop where it's more of a request when you push the rudder. So in the SolidWorks scenario that you saw, what's happening is there is values, your customer's values that you're punching in. Those values are going to essentially an onboard computer behind SolidWorks. And in this particular case, it's the TactonWorks engine. The TactonWorks engine is evaluating all of the inputs that you've given, along with all of the attributes that it knows might need to be changed, as well as any rules that you've put in place. So for example, if you have one type of base that's 6 inches long, it knows that it can't place a clip, or you tell it, you can't place a clip 6 inches from the edge when it's this type of base. So it's evaluating all of these things, and then it's coming up with a valid set of values and pushing those back into SolidWorks. Okay. Now, to get back to your question, the challenge of design automation is if you look at the numbers of different parameters that we're changing, all right, 3 different base styles, and you could have 1 or 2 or 3 or up to, in this case, almost an unlimited number of clips because we didn't put a max on it, and you start multiplying these options together times the type of material times the whether or not those bases are bolted on times, you very quickly end up in millions or even billions of possible combinations that get pushed back into the system. And you have to set the system up in a way that SolidWorks isn't going to break when you push in any one of those sets of values. Does that make sense? And you all have been using SolidWorks for a while. I'm going to make the assumption. You know that whenever you do something like that, the odds, when you do it manually, other parts of your system you're going to have to go and fix things because mates aren't going to work. Or if you do a component replace, that might break some mates, so forth. So there are certainly tips and tricks when you are setting up the models, those master models, so that no matter what values get pushed in there, they're not going to break. And for that particular one, your question of what we dimensioned that to, we'll show you in just a second. From experience, let's say the number one thing which trips people up are mates, especially when you're doing component replace, because you can't make any assumption that the component that was originally there is going to have the same entities as the one that you replace it with. Okay. Yeah, just a couple more of these. But again, what he was able to do with by merging additional modeling into what you originally saw with the crate was largely because of he had the time because the crates were already there. just sort of a visual for what I was talking about as far as how much you're going to automate. And I've seen a number of examples where, hey, if there's just one task and it's done over and over and over and over again, automating that one task frees up engineers so much that it's worth the investment. So going back to the conversation with the owner of the company, the effect on other parts of the company outside of engineering was almost more significant than the effect of increasing the productivity of the engineering department. So if the engineers don't have work to do, if there aren't sales, then all of this is a moot point. And for the first time ever, they were generating quote drawings with every quote that went out. And so, one, they were looking much more professional to their customers and therefore having a higher hit rate. But also, Landy, what were you saying? You were mentioning that the responsiveness of being able to get quotes out,
Right.
the speed.
Right. The sales team, we try to get the quotes out before the customers can shop around, because the last thing they think about when they're shipping something is how to get it there. So.
Exactly. So what they've found is that by being the very first one to respond and respond with something that the customer can actually see, yep, that's exactly what I want, their hit rate has gone up. And that's tied directly to the next slide, which is being able to do these drawings for everything that comes through the door. Which is that. Now, on the other end, not just the quoting side, but on the standardization side with respect to manufacturing and engineering, as you saw, now everyone that gets created gets exported to a consistent file structure. And so every document is always in the same place, it's always treated the same, and anyone who uses the system always has the results pushed to the same place. Again, that consistency means they don't lose things. Second of all, people on the shop floor who are doing assembly know where to find things, and because they have a visual picture of what they're trying to build, they're making fewer mistakes, so less rework. And there were a couple of examples that they talked about with me. The first was on the approval drawing side. Within the first week that they were using the system, they got word back from one of their customers, wait, don't produce that yet. The stringers are in the wrong direction for what we need, for the way we're going to be loading these things. No way they would have known that if they didn't have a picture. And then there was another one. I can't remember if there was another mistake.
There was another time shortly after. It was one of those drawings that was in there. It was a large crate order for about 100 crates with a possible order of 4,000. And I sent them the dunnage drawing, and the part that they sent was the wrong part. So I had made the dunnage for the wrong part, and then they didn't notice it until I actually showed them the crate. This is how it's going to be, and they were like, "Whoa, stop, back up, let's rework this."
Right.
So
again, none of it's rocket science, but it is process improvement and simple stepwise process improvement that has completely changed the way their business works and the way they interact with their customers. And that's sort of this last slide, which is in terms of, one, the professionalism. Landy told me that at least one, but several of their customers who they had for a long time made it a point to get back to them when they started receiving these quotes with the drawings to comment on the value of the improvement to them. But then also Landy was sharing with me just the nature of how this has changed the view in a relatively small company to the value of technology and changing the culture. And so the things already that I'm seeing happen subsequent to this are pretty significant. So we sort of got a snowball rolling. So let's look at the implementation just a little bit. We've got about 15 more minutes. Here, let me jump up and show the model. Again, this is a little different than most presentations I've done in the past. I've never done a customer success story, so to speak. Usually it's more technical by nature. But are there any questions with respect to why some of the things that you saw were done, or just general questions speaking to this process?
Were there any ROIs? What was the ROI calculated based on the solution?
The return on investment was in this particular case nearly weeks. if you'll yeah, let's not go there. Okay. So if we just look at the SolidWorks modeling for just a second, view model types. As we were going through some of those pictures, you guys, again, because this is such a simple modeling from a SolidWorks perspective, none of what's actually happening is very difficult. It's difficult to imagine how you might do it. There is both for the components in the assembly, there are patterns being used for the clips. For the slots that are being carved into each panel, again, there are panels being used, or patterns being used. For the base, let me just flip through sort of some examples here. Things that they wanted to do were, for example, they wanted to automatically suppress and unsuppress certain features, like holes, if they're reusable crates, which is one of their categories. The higher price crates, then they need to be bolted down to the base. If they are one-way crates, you end up with different material and no holes because they're just nailed on, so forth. So when you think about the design automation, basically you are taking apart and either directly changing dimensions, you are suppressing or unsuppressing features, you are swapping SolidWorks configurations for other configurations, or you're doing component replace between one component and another component. And in all of those things, you want to set up your models so that they are completely robust no matter how they get changed. So, in this particular case, what I like about this particular tool is that all of it's right inside of SolidWorks. And so at any time during the configuration process, we can be looking at our master model. So there are these panels, top, end, and 1 and 2. The sides are the same. And in this particular case, we used a somewhat common technique that that solved a lot of problems for us, and that was using a reference geometry that we think of as a ghost part, because all of these crates are fundamentally based upon a rectangular prism, and so in our assembly we have a reference geometry and we have a block. That block right now is hidden, but if we show it, it looks like that, and if we isolate it, oops. In fact, if I undo that, we're driving the size of a cube, and then everything else is getting mated to that cube. And then as we change the size of the cube, everything follows along. And the reason that, that if you were not doing design automation, that may seem like a workaround that's almost a little tacky, if you will. But what that enables us to do is ensure that if that block is always there, any components that we swap out can be mated to exactly the same block that is always going to be there. And they can be mated to the same positions on that block. So all of those clips, or all of the seed clips, which then get patterned, can be mated to that block, which is the outside dimensions of the crate. What that means is, if in the future I replace any of the panels, there aren't going to be any broken mates between the clips and the other panels. What it also means is that down the road, there are additional types of crates that they create. Some of them have split panels, where instead of just having one panel on the side, it would actually be an assembly with seams. Or they have some other scenarios where the panels fundamentally are different than the ones that they use 80 or 90% of the time. So in the future, we'll be able to swap those out, and none of the mates will break because they'll be mated to that block instead of to other panels. Okay? So that's one. Versus
square box versus a rectangle, where we actually use it at a different angle.
Okay. So that's one trick. But then the other question that you asked earlier about what do we dimension? Now that we've shown you that, you want to guess what we dimension to? Just dimension the cube. Yeah, because no matter what happens, our dimensions are always going to be 100% clean because they're tied to that cube, which is hidden, but it's always there. So many times, generating the models themselves are often not that difficult, but producing the 2D drawings where you have dimensions that are changing, dimensions that are tied to elements that are changing, is where you end up with a lot of blood in the water. So tricks like that, tricks like the utilizing of other types of reference geometries, planes and so forth, is immensely useful. In fact, one of the, I don't think we did it in this one. Did we use coordinate systems for the base? We can look at the model. There's a reference geometry for coordinate systems. Is everyone familiar with? You can add planes and axes. You can also add coordinate systems. And by creating coordinate systems in your component parts and then adding the mates between those coordinate systems, it's another way to create a lot of robustness in your model when things are changing. Because if you name coordinate systems consistently, then you only have one entity that is going to be mated, instead of the typical three in order to properly position something, and if you end up with a component that is completely different than anything else that it might be replacing, you can add a coordinate system without any other legwork. Same way you do? Yeah, I found it to be immensely valuable. Were you going to show something, Paul?
I was just zooming on the corner so you can see the dimensions are actually
Got it.
filled in, so you have to-
Got it. Oh, you're on time. Okay. So from a technical implementation standpoint, are there any questions? Or would you like to see anything more? Not so much. Okay. Say again?
He wants to know if anybody wants to try to put the box together.
Does anyone want to try to put the box together?
It's kind of fun.
Yeah.
Paul did it. So just a few minutes left. If no one has any questions, let me speak just to one final aspect, and that is, what's the alternative? And so, before I started really focusing on design automation, I was using SolidWorks, built-in functionality, design tables, configurations, equations, to attempt to solve a lot of these same types of problems. And what I found was, configurations, for example, for a very specific purpose, they're immensely valuable. But in production, where you're actually going to be producing volume of any type of design, they quickly become a disaster. There are too many possible outcomes. And that's what I was finding when I was working at a company, for example, where we had a 300-page catalog of different components that went together in a myriad different ways. And I was spending time trying to predict what the customers would need, what combinations, what sub-assemblies might be needed. And for as many as I would create, or as many sort of what I thought were robust solutions, what we actually needed on the next job was something that I didn't quite have. And then once I started to get into design automation, I realized that the reason that a lot of projects sort of fizzled was because people didn't appreciate, thank you, people didn't appreciate the size of the mountain that they were trying to scale. And so if you look, for example, on this one, and again, you don't get many products that are simpler, than a rectangular box. And yet, if we play that game and start to say, okay, we've got length, width, and height, we've got the number of clips per edge, and that could be anywhere from 1 to, let's say, 10 for reasonable scenarios. And the offset distance could be any number of set standard values. And then, all of a sudden we have a situation where we may want 2 clips between every block on the stringer. Sometimes we want 1 clip on every block. When you multiply together all those combinations or set up all of those numbers of configurations, you can't do it. The size of the mountain, the number of things that you're trying to configure, ends up with combinatorial explosion. And so by having a system that enables you to write those rules and create configurations on demand, which, if I were to go back to SolidWorks, there are no configurations being used in any of those models that you saw. Ends up being the way that you can create the types of benefits and savings that Landy was talking about here and that the owner of his company was talking about. So with that, if there are questions, we'll wrap up. And appreciate your time. Feel free to come on up and either talk shop or take a look at the crate, or any of the above. So again, appreciate it. Thanks for your time.